Okay, now they were very unkind to you here because they didn't give you any graph paper, but let's go through quickly. So the tension force in the cable can be resolved into a horizontal component and a vertical component. What does that mean? It means the cable is pulling down and to the left, and what we're saying is that that is the same as pulling straight forwards and straight down, as if there were two separate forces, one pulling forwards and one pulling down, and we call those two directions the components. And we can figure out how big they are by drawing a scale diagram. So what you would have to do, now I'm not going to do this measured because I can't on my iPad, but you would have to draw a straight line at an angle of 20 degrees. Then, what you'd do is you'd say, what would be a good scale to use? Maybe you'd say 500 newtons is equivalent to 1 centimetre. Okay, so this line here would then have to be 4 centimetres long, because 4 centimetres therefore is 2,000 newtons. Yeah, hopefully that makes sense. So each centimetre is 500, so 4 centimetres is 2,000, and 2,000 is indeed the size of the force. So that's going to be 4 centimetres. Then, what direction is this? Okay, so this is acting downwards. So then what we're going to do is we're going to complete this. We're going to turn it into a triangle, okay, a force triangle. So that looks like that, going to the left, and this going down like that. So this is just going to be a right angle. And then what you have to do, and sorry, of course, this has to be 20 degrees. And then what you have to do is measure, using a ruler, that length. And then you also have to measure that length. Now, if you do that, and if you use this scale, then what you would find is this should be, I'm just working it out, this should be 3.8 centimetres. And this should be about 1.4 centimetres, okay? This angle that I've drawn here, because I'm just approximating it, I'm sketching it, this is actually a lot bigger than 20, so this doesn't quite look right. But when you did it, if you measured this angle accurately and you measured this length accurately, then you should find that when you turn it into a triangle, these are the distances. And then you have to go back to your scale and you say, right, so what's the distance? It's going to be 3.8 times by 500 newtons. That is 1,900 newtons. And 1.4 times 500 newtons is 680 newtons. Like that. Okay. So that was quite a tricky question. So we'd have to write down, oh, here's the answer here, 1,900 and 680. Okay. So we could add arrows. So that's downwards and that's to the left. Just to go over this quickly, just to reiterate. So we'd have, if we were just adding the vectors, so let's start up in this corner and we're going to add the two components. So let's add the vertical component first. So we'd go down to here, that's the first component, and then we go tip to tail and add the next component, which is this one. And look, we end up in exactly the same place as if we'd just gone straight. Let me do this in a nice bright colour. If we'd just done that in the first place. Sorry, that's not very straight. I should straighten up. There we go. So if we'd done that in the first place, it's the same overall force. So the two yellow forces together, they give the same effect as the pink force down the hypotenuse there. Okay, so that's the two components, and that's how you work them out using a scale drawing, and those are the two correct answers. Okay, So let's go back onto here. All right, describe the difference between solid and gas states in terms of arrangement and movement of particles. So it's 4 marks. I was really happy with what everyone did here because everyone gave loads of really good information. The only thing that people forgot, well, I'll get there in a second. So solid, the first thing to say, you must use the word particles. Particles, particles. Particles vibrate about fixed positions. That's the first thing to say. And the second thing is to say that they are closely packed. Okay? Because look, it says in terms of the arrangement and movement of the particles, okay? Don't forget to answer the question. Some people gave loads of detail about energy and internal energy and all of the kinetic energy and everything like that, and that's really good knowledge, but don't forget to answer the question. Describe the differences between solids and gas states in terms of their arrangement and movement of their particles. That's all you have to do. So in a solid, we know, everyone wrote this, particles vibrate about fixed positions. We've said it a million times. That the arrangement, they are closely packed. So you could say, you could also say regular arrangement. That's another thing that you could say. But the fact that they're closely packed together is important. What about in a gas? So in a gas, you have to say the particles again. So particles underlined. Okay, don't say the word particles, you don't get the mark. Move randomly. Randomly, random directions with a range of speeds. And again, most people wrote that. But in terms of their arrangement, that's how they move. But they are far apart. Okay, so that most people didn't say that last bit, far apart. The fact that the particles in a gas, they are distant from each other. They're not touching. They're a long way away. Okay, final one. What is meant by specific latent heat of vaporization? We've got the word specific again. That means it's per kilogram. We have to say that. So we would have to say, again, energy required to change 1 kilogram from liquid to gas. Okay. Now, most of you said at a constant temperature, and that's perfectly correct. It actually wasn't in the marking scheme, but it's good practice to put it in there, so we can say at constant temperature. Constant temp. Okay, good. We've got a minute and a half left. Let's see if we can get this one. So when a kettle boils, 0.018 kilograms of water changes to steam. Calculate the energy required. So this is easy. So the energy is the mass in kilograms times by the latent heat in joules per kilogram. And that makes sense. If I do joules per kilogram times by kilograms, I get something in joules. So it's just about plugging in 0.018 kilograms times by 2.3 times 10 to the 6 joules per kilogram. And we get an answer of 4.1 times 10 to the 4 joules. Okay, let's pick up in the next video.